In this video, I'm going to show you how to calculate the molar mass. Your teacher might use some other names like molecular mass or formula weight. No matter what name you see from this list, they all mean one thing: molar mass. The molar mass unit is grams per mole, which can be shown by one way like this or another way using this slash. In this video, I'm going to show you the calculation of molar mass for several formula, and you can see the complexity is increasing down this list. Our first example is water, H2O. When you see a subscript right after the element symbol, that subscript represents how many atoms you have from that particular element. So here H2 means you have 2 hydrogen atoms, and after oxygen you do not see a subscript. When you don't see a subscript, by default that means you have number 1 here as a subscript, only that we don't show it. So that means you have 1 oxygen atom. Now we need to know how much each of these atoms are going to weigh. In order to get that information, we need to go to the periodic table. When we go to the periodic table, you can find some information for each and every element. You can see the atomic number, we have the symbol, name, and then here you can see the atomic mass. This is what we need to calculate the mass of each and every element in the given formula. Now let's do the calculation. We have 2 hydrogen atoms, each weighing 1.01. To that, add 1 oxygen atom weighing 16.00. Here I have broken down the calculation so that you can see how to proceed with the calculation, and you can see the final number you get is 18.02. Don't forget the unit. So what this actually means is that 1 mole of H2O molecules is going to weigh 18.02 grams. 1 mole of H2O weighs 18.02 grams. Our next example is C2H4O2. C2 means we have 2 carbon atoms. H4 means we have 4 hydrogen atoms. O2 means we have 2 oxygen atoms. Now we can go to the periodic table and find the information we need. The information we need is the mass of each and every element. We have 2 carbons, each weighing 12.01. We have 4 hydrogens, each weighing 1.01. And then we have 2 oxygens, each weighing 16.00. When we do the calculation, we can find this as our molar mass. So that means 1 mole of C2H4O2 molecules are going to weigh 60.06 grams. The next example is magnesium nitrate. Now this is a formula with parentheses. When you see parentheses, there is a number outside the parentheses. This number, the subscript outside the parentheses, tells you how many times this portion is repeated. So this subscript that is after the parentheses belongs to everything within the parentheses. So basically it means we have 2 nitrates, and you can see magnesium has no parentheses. So we have 1 magnesium and 2 units of NO3s. Now you can count how many atoms you have from each and every element. we have 1 magnesium and 2 nitrogens, and you can see we have 6 oxygens. Now we have listed how many atoms we have from each and every element, and rest of the information we can get from the periodic table. Now 1 magnesium and its weight, we have 2 nitrogen, its weight, and then 6 oxygen and its weight. This will give us the molar mass of magnesium nitrate, which is 148.32 grams per mole. That means if you take 1 mole of magnesium nitrate, it's going to weigh this much. Our next example again contains parentheses. You can see the subscript 3 after the parentheses. That means this NH4 part is repeated 3 times. Now we have phosphate, and then we have the NH4 parts. You can see I have repeated it 3 times. Now you can count how many atoms you have from each and every element. You can see we have 3 nitrogens, we have 12 hydrogen atoms, 1 phosphorus, and 4 oxygen atoms. Now go to the periodic table, get the masses for the elements we are interested of, and then start calculating. 3 nitrogens, we have 12 hydrogens, we have 1 phosphorus, and 4 oxygen, which is going to lead to the molar mass of 149.12 grams per mole, meaning 1 mole of ammonium phosphate is going to weigh this much. This is our last example, MgSO4.7H2O. Now this is a little bit different one from the previous one. We have a dot. So what this simply means is that we have magnesium sulfate, and then it is surrounded by 7 water molecules. Now this is a much more pictorial way to show this formula. Now if you count the number of atoms for each and every element, we have 1 magnesium atom, we have 1 sulfur, we have 14 hydrogen atoms, and we have 11 oxygen atoms. You can see that you can find oxygen here with magnesium sulfate and also with oxygen. And then get the atomic masses from the periodic table. And then we can do the calculation. 1 magnesium, we have 1 sulfur, 14 hydrogens, and 11 oxygens. Once we get all these numbers added up, we get the molar mass. So that means 1 mole of magnesium sulfate .7H2O is going to weigh 246.5 grams. Now you have practiced calculating molar masses for formula with parentheses, with dots, and even simple ones. Now you can actually calculate molar mass for any formula that you find.